Hello everyone, I'm HighSchoolPhysicist. Welcome back to my channel. This festive season had pushed back the production, but certainly does not push back the productivity. My motivation in creating this channel is to talk about some topics in physics for the audience at high school level or above. This channel emphasizes mathematical tricks that are used by physicists that may be appreciated and learned by young students, and finally can attract young generations to love physics. Today I'm going to be talking a topic called spontaneous symmetry breaking. The agenda for today are symmetry breaking non-spontaneous. The third is spontaneous symmetry breaking, and then case number 2, and then conclusion. Before starting, let me mention the maths needed to follow my story in this video, which include algebra, function, and trigonometry. Like explained in my previous video, symmetry is object transformations in mathematics that leave that object unchanged. Some examples with regard to space are translation, reflection, and rotation. Let us take a look at a vacuum three-dimensional space, which is left is symmetrical to right, front is symmetrical to back, and up is symmetrical to down. Now, let us take a look at space near Earth. Left is still symmetrical to right, front is symmetrical to back, but up is not symmetrical to down due to gravity. This is an example of non-spontaneous symmetry breaking. There is agent to break the symmetry of up and down, that is the gravity. So, what is spontaneous symmetry breaking? Let me illustrate an example. Let us now use an example. Fx equals to negative ax squared plus bx to the power of 4, with a and b are positive numbers. And for the real example, let us set a and b to 6 and 3. The next logical step is to plot this function. We see that this graph is symmetrical with respect to y-axis. And physicists are interested in the extremum points, which are A, B, and C. But in this case, point B is unstable, so physicists must use the most stable points, which are A or C. Let us now select C or C1. C is the point when we use x variable, and C1 is the point when we use x1 variable. Then we have to change the suitable variable. Let us use x1 equals x take away 1. Then we can calculate f as a function of x1 as follows. We see that fx1 has no longer symmetry with respect to line x1 equals 0. This is called spontaneous symmetry breaking. We see that there is no external agent to break the symmetry, but the physics phenomena let the symmetry break by itself. So the first, we inspect a symmetrical graph, then select one of the minima and change the variable. Why did we select fx equals negative 6x squared plus 3x to the power of 4? Here I present 4 options. The first option is fx equal to negative 6x squared plus 3x to the power of 4, which is negative and positive. The graph is stable and spontaneous symmetry breaking occurs. The second option is plus and minus, which is also stable, but no spontaneous symmetry breaking. The third option is positive positive, which is stable, but no spontaneous symmetry breaking. And the last option is negative negative, it is not stable. Now we enter case number 2. I remind you fx equals negative 6 x squared plus 3 x to the power 4. And then now we introduce two variables. And the function is g as a function of x1 and x2 as shown on the screen. And then the next we plot in a 3D plot. We see that the minimum happens at x1 squared plus x2 squared equals 1. How can we select points x1, x2 for x1 squared plus x2 squared equals 1? There are 4 options that I wrote here. The first is x1 equal 1, x2 equals 0, or x1 equals 0, x2 equals 1, or x1 equal x2 equal 1 over square root of 2, or the last one is x1 is sinus theta and x2 cosinus theta. As you see that usually physicists pick the last option. Hence, the function g as a function of x1, x2 and theta is as shown in the screen. In conclusion, we have learned about spontaneous symmetry breaking, which is the symmetry breaks by itself without an agent. We give an illustration. First, we inspect a symmetrical graph, then select one of the minima, and lastly, we change the variable. And here is the example. Fx, and then let x1 equal x, take away 1, and then the new function will be x as a function of x1. Additionally, the coefficient of x squared or x1 squared has flipped from negative to positive. In physics, it is said that the system has acquired mass. It means that the system was massless but now massive. In this occasion, I would like to thank my fellow Dark Calligraph who provides solutions in the web technical and also marketing matter, considering subscribing to his channel. See you next time and thanks for watching.